Hi students, welcome back to the channel. Today I am going to discuss about the derivative of exponential function and logarithmic function. Before going to find the derivative, what is an exponential function? What is the logarithmic function? An exponential function is defined as f of x is equal to a power x, where a is the base, is the positive real number. A must be a greater than 0 and it should not equal to 1. Why a should not equal to 1? 1 to the power of anything is a 1 only. That's what. And where x is exponent. Where a is the base and x is exponent, a must be the positive and should not equal to 1. Same way, a logarithmic function is a inverse of an exponential function, defined as f of x is equal to log x base a if and only if a power f of x is equal to x, where a must be a greater than 0, a should not equal to 1, and here x must be a positive in real number. Logarithmic function is defined only for the positive real number. Be careful. In the logarithmic function there is a two categories there, that is an common logarithm and natural logarithm. What is a common logarithm? If the base is 10 is there, if base 10 is there, then that is called as a common logarithm. Log x base 10 is equal to y. The corresponding exponential is 10 to the power of y is equal to x. In the natural logarithm, the base must be e. Base e. The corresponding exponential is e power z is equal to x. Okay, now here e is the constant. The value of the e is 2.718. Then some common property of a natural logarithm here. The log x base e is symbolically ln x is the inverse of natural exponential e power x. It is n. Then base e, while common logs use the base is 10. In the common logs, the what is the base? Base is 10. In the natural logs, the base is e. Log x, otherwise log x base e. Ln x, otherwise log x base e. Then some properties of the natural logarithm. Ln 1, otherwise log 1 base e is 0. Ln e value is 1, and log, otherwise ln x into y is ln x plus ln y. Log x by y, otherwise log x by y base e, that is a log x by y is a log x minus log y. Multiplication is there plus, the division is there minus. Then log x power y is an y log x, otherwise ln x power y is an y ln x. Okay, na? These are the important. We know that the exponential and logarithmic are the inverse process. The graph of the e power x and log x base c graph is this one. These are the reciprocal. They are the inverse to each other. The mirror image, the which is the act as a mirror for these two function log x and e power x, the y is equal to x act as an mirror for these two functions. Okay, these are the diagram, graphical representation of log x and e power x. Next we will move on to the example. First one, find the differentiation of sine of tan inverse e power minus x. Okay, now first step is that here I will take as a three function is there. Outer function is sine, inner function is tan inverse. still more inner function is e power minus x. There is a three inner function is there. Chain rule. First act as a sin x. What is the differentiation of sin x? Cos x. Cos x. Again this we have to differentiate. Differentiation of tan inverse e power minus x. Again this as an tan inverse x. What is the differentiation of tan inverse x? 1 by 1 plus x square. What is an x here? E power minus x. This function as it is, cos of tan inverse e power minus x. Again this tan inverse e power x differentiation is 1 by 1 plus x square. X value is e power minus x whole square. Again this differentiation of e power minus x, differentiation of e power minus x is minus into e power minus x differentiation, that we wrote final answer here, that is an minus e power minus x is a differentiation of e power minus x. Remaining two terms as it is, this is an as it is in the numerator, in the denominator 1 plus e power minus x to the power of 2 a power m into n is an e power minus 2x. A power m whole power n is equal to a power m into n. On the basis of that one, this step they wrote. Okay. Next example. What is an? Find the differentiation of cos of log x plus e power x, where x must be greater than 0. First, cos x, differentiation of cos this as an x. What is the differentiation of cos x? Minus sin x minus sin u. Again have to differentiate this log x plus e power x. This is an cos become minus sin log x plus e power x. Again I have to differentiate this log x. Differentiation of log x is 1 by x. Differentiation of e power x is e power x. So that differentiation of this inner derivative is an log x is 1 by x, e power x is plus e power x. Okay, now complete what is done. First differentiation of cos of log x plus e power x is an minus sin log x plus e power x. This differentiation is an 1 by x plus e power x. Okay, this is a second example. Next, logarithmic function. How to derive the logarithmic function? Which type of an functions we should apply the log, afterwards we have to differentiate is nothing but as an the function is the type of an u to the power of v, otherwise f of x to the power of g of x. Any function to the power of another function is there. Here y is equal to u of x to the power of v of x is there. Okay, this type of functions are there. We have to apply the natural logarithm. We have to apply the log and we have to differentiate. Okay, this is an important category. When we should apply the logarithm to differentiate means that functions must be the one function to the power of another function, u of x to the power of v of x. Next, taking a log on the both the side, that is a log y is equal to this. If I apply the log for this function, then v of x is come back side, v of x into log ux. Again have to differentiate this one. Differentiation of log y is an 1 by y. Again this y differentiation is dy by dx. Next I will use the product rule for these two functions. First function as it is, differentiation of log of u of x. Differentiation of log x is 1 by u of x. Again I have to differentiate this u, that is an u dash of x. Next, I have to differentiate this function. First function I am differentiating v dash of x. I am keeping this function as it is. Okay, then I will send this y to this side. Y is dy by dx is equal to y into this Vx by Ux, then U dash of x plus V dash of x is into log of U of x. Okay, this is the way we have to differentiate by applying the logarithm. Example for that one. First one is that differentiate x to the power of sin x with respect to x. Now x to the power of sin x, it means that it is in the form of an u power v. Now in this case I have to apply the log on both the side. Log y is equal to, when I am applying the log for this function, sin, it will come back side, sin of log x. Now I am going to differentiate with respect to x. Differentiation of log y is 1 by y, again dy by dx. I am using the product rule for this one. Keep this function as it is, differentiation of log x, plus keep log x as it is, differentiation of sin x. Now 1 by y dy by dx is equal to sin x as it is, differentiation of log x is 1 by x. Then log x as it is, differentiation of sin x is cos x. Now this y I am sending this side. Dy by dx is equal to y into sin x by x plus cos x into log x. Now this y value I am going to substitute. What is the y value is there? X to the power of sin x, that is an x power sin x, remaining thing as it is. Just if you want to take as an x common here, we can write it as an by x, that is an x to the power of sin x minus 1, because this is a x to the power of 1 na? It will go to numerator, means x to the power of sin x minus 1, this sin x as it is, plus x power sin x inside this two term as it is. Okay na? Next, second example. Differentiate y is equal to x plus 1 by x to the power of x plus x to the power of 1 plus 1 by x. Now this function y is equal to u plus v. I am taking this as an u, this as an v. Okay. Now first function I am going to differentiate u here, because this is a u to the power, it is like a function f of x to the power of g of x, like that, one function to the power of other function. For that I am going to apply the log on both the side, log u, then x will come back side, x into ln x plus 1 by x. Okay na? Please you have to understand, log is nothing but a natural logarithm, it must be base e. Okay, then I am going to differentiate this one. Differentiation of log u is a 1 by u, again du by dx. Next, differentiation of x is 1, that is 1 I didn't write here. Then this second function as it is, ln x plus 1 by x. Afterwards I am keeping x as it is, I am going to differentiate ln of x plus 1 by x. This like a log x is an 1 by x. Again I have to differentiate this x plus 1 by x. Differentiation of x is 1, then differentiation of 1 by x is an minus 1 by x square. How we can differentiate? 1 by x take as an x to the power of minus 1, differentiate in the rule of x power n, you will get as an minus 1 by x square. Next, du by dx. This u I am sending this side, that is an u value. What is the u value is there? U value is x plus 1 by x to the power of x. Next, this log, otherwise ln x plus 1 by x as it is. Now if you simplify, take as an x LCM, x square plus 1, then this x, it will go numerator x square by x square plus 1, then here LCM if you take means x square minus 1. This x square get cancelled, x square minus 1 by x square plus 1 will be remaining in the second term. Okay na? This is the du by dx. Same way I am going to differentiate this one, v. Same function to the power of another function, take a log on both the side. Log v is equal to this 1 plus log x will come back here, then log x. I am going to differentiate. Differentiation of log v is then 1 by v, then dv by dx. Then I am using the product rule, this one. Differentiation of u, that is then differentiation of this 1 plus 1 by x. Differentiation of 1 is 0, I am not writing here. Plus differentiation of 1 by x is then minus 1 by x square. This log x as it is. Again, first function 1 plus 1 by x. This differentiation of log x is an 1 by x. Now I am sending the v that side. Again I am substituting the v value as an x to the power of 1 plus 1 by x. Then this x square is an LCM. Then here what is left here? Log x minus log x is there. Minus log x I wrote here, x plus 1 will be the, because x square I am taking left, if I take as an LCM is x plus 1 will be there in there. X plus 1 will be here, minus log x is an here. This is an dv by dx. Finally dy by dx is equal to du by dx plus dv by dx. Here du by dx is there, dv by dx is there. Okay. Next, this is the last one. Next we are going to differentiate the some more example on the inverse trigonometric function, sorry, logarithmic function. Thank you so much. Bye. Take care.